Elvis? Yeah. Okay, so we'll go back to point 2. That's our default. So here's the infill density. So its default's to 10%, guys. So we could increase this all the way up to solid. We could do 100% infill. It's going to take a lot longer. Not only is it going to use more material, it's going to take a lot longer. So default is 10. You could even go, I guess you could do none. You could do no infill. So let's keep it at 10. I'm going to show you how to preview the print so you could see the difference between these things. I would say this is maybe your most important setting. The shells. I wish I had a dry erase marker. Alright. What else is a piece of paper? Okay, say I'm cutting through a sphere. There's one layer of filament. It defaults 2 layers of filament. And then it's going to print 10% infill. Right? So this is the setting. So these are continuous, you know. So you could, I like to sometimes up this to 3 layers or 4 layers. Instead of messing with the infill, I'll just add additional layers of thickness to the shell wall. So that is something that you could play with. So you could do 2, very durable, but you see how much slower it gets. Very delicate. So 2 layers at least is less delicate. 3, 4 starts to become more durable and tough. Yeah, it's not going to break. But let's just leave it at 2 for now. The printer, this is the speed that the extruder moves. So you might preview this and it's going to say, oh, it's going to take 42 hours. And that's fine if there aren't like 89 of you waiting to use the same machine. And we have other machines at MBUS that you may want to take advantage of. But you may want to try to not print things for 42 hours because not only does it inconvenience everyone else, the likelihood that there's going to be a mess up goes up exponentially by the minute. So the longer it's running, the more likely it is that at hour 39 it's going to mess up. And then you have to start over and do another 42 hours. So you want to bring the speed down. So some things you can do, this is 150 millimeters per second. That's how fast the extruder is moving and depositing material. You could speed that up. Right, so we can speed this up. But you see it says that the extruder is knocking over taller, unstable parts. Slow the travel speed down, right? Because sometimes it moves so fast that the part starts to stick to it and you'll just tip it over. So again, this is the standard speed that's recommended. I don't know that you need to mess with this too much unless you're knocking things over. But you could try to speed up the travel speed of the print head. These are the temperatures. Also, if you notice things are getting globbed up, you may want to increase the temperature. But I would, again, these are intended for hobbyists. I would kind of leave that. So sometimes what happens is that as it's slicing and it gets to the top, because it's all infill underneath, it's printing a solid sheet. Like this is a plan view. And then it's going to print a solid sheet back and forth, right? So because there are gaps underneath it, there may be, it's not solid underneath, but it's printing a solid thing on top. It may start to slump and do some things like that. So that's this roof thickness. If you'd like a stronger print, increase the roof solid thickness. So right now we have 0 millimeters. Some of these are new settings. Okay, we did shells. There's your infill. Floors. Supports are kind of interesting, all right? So floors, again, that's the first layer, almost like the roof thickness. But the thing I want to point out is this, supports and bridging. Can I expand this?
So this is like scaffolding. Have you seen how they build concrete construction, how they pour a floor slab? They put up temporary centering. They put plywood up, they pour it on top, and then they take that stuff down. So again, it says here, like if you're printing something that's supported at the edges, building up columns, but then when it goes to draw across, it's all just going to slump in space. So it'll print temporary breakaway supports, and then it'll print on top of that, and then you have to break all that stuff off. It sounds ideal. It's really difficult to break all that stuff off like cleanly. And there are some 3D printers that will print with two different materials, so the supports are water soluble. So you'll take out your part, put it in water, and then the supports will just dissolve away, and you're left with the thing you want. These are not that. Like, those are more expensive. So, you know, you probably want to use supports under bridges. Adjust the angle of the surface. This is preset to 68, which means if I have something like this, if I rotate it 68 degrees, then it'll be able to just sort of print a cantilever, and I won't need those supports. So that's something you can like enter in our manual thing. So what I want to see is if it puts supports here. That looks steeper than 68. All right, so let's just go with that for now. All right, so this is going to tell us how long this should take. What's that?
Already printing so long?
It takes a long time because, again, it's slicing through this thing, it's calculating supports, and it should give us a rendered view of what it will look like. Here you go. And it also outputs, it's the same with the CNC milling machine. It's showing us this, but it outputs just a string of characters that basically tells the printer where to move and how fast to move and how hot to get and things like that. All right, see it? What's that? All right, so look here. So I don't have any support material, which is good. No supports. All right, so see each one of these. See my 10% infill? See, that's the infill? Yeah. And again, if I increase that to 20%, it's going to be twice as dense, yeah? All the way up to solid. And you see the 2 layers of shell thickness here. I recommend you go with the standard settings. And then if you want to try to adjust some of them and compare the differences, go for that. Also, this thing is the raft. So see, it puts on a raft first. You just break that off. And it says your time estimate, 1 hour and 50 minutes. And it tells you 21 grams of material needed. Usually in every school, I've taught at 5 universities, we always charge students by the weight of their part. So you're using 21 grams, you just pay for the material. We don't charge you, I think, right? Mike doesn't charge you?
No, we just have like 30
After 30 hours.
30 hours a week.
Yeah, you just figure out.
Oh, okay. It's weird to charge by the minute and not the weight of the material, because really, that you buy it by the pound, you buy all the spools by the pound. But let me show you something, for instance. How do we close this? I want to change the settings one more time. I want to rotate this a little bit. All right, look. I've now leaned this thing over. All right, you wouldn't really want to do this, but say you did. Say you had a part like this. All right, so this should print support, because it can't just start printing off. It's all just going to start drooping in space. So let's see what happens here. Okay, I restarted the recording. Okay, the last step, everyone. Is this what I export? Export. Okay. Okay, Boolean cube 3D print. But I don't, is that correct? Who went through this process? Is that what I export? I thought usually down here at the end of this site is where I export it. So just that? Okay, look, we did it. Great.